Hi folks, welcome to 3.7 Rational Functions, Part 1. So let's start off the same way we start off every lesson, which is talk about what we know and then expand upon what's new in this particular section, okay? So let's get started. What we know. Well, we know quite a few parent functions so far. Okay, so we know a lot of different parent functions, and let's just kind of list them out here so we can remember them. But we know that we can have f of x equals x, absolute value of x squared, square root of x cubed, e to the x, and the natural log of x. All right, now those are graphs that we've learned throughout our semester, and they're super, super important to really keep in the back of our brains that we know the shape of all of these functions, and we know some important characteristics. Okay, so some of the characteristics that we should know or be able to tell from a graph include end behavior. Right, that's kind of been a big one for us. What happens at the ends of a particular function? We've looked at some of the functions have a horizontal asymptote, some of them have a vertical asymptote, and knowing when they happen and when they don't. We've also learned how to find x-intercepts. And as a friendly reminder, that's going to be a number, comma, 0. And we've looked at y-intercepts, which are going to be the other way around, where we plug in 0 for x and out comes a number for y. And then using all of this information, we've talked about our graph transformation. Okay. Talked about our graph transformations and how we have different numbers in different places that help us figure out what happens to the function. And we have our C value, our B value, our A, and then our D value, and they have to happen in that order, okay? So if any of that's unclear or unfamiliar to you, go back to some of the earlier videos and notes to catch yourself up on that. But what we're going today is we're adding one new parent function to the mix. And this function is called the reciprocal function. And this function looks something like f of x equals 1 over x. Okay. We're going to be doing that in this video. And then when we meet during class, we're going to take a look at functions that have a whole bunch of weird things happening. They have horizontal asymptotes, vertical asymptotes. They might even have holes in the function, okay, or points that are missing from the function. And we're going to take a look at that as a class together on Monday. Okay, so that's our what we know and what's new. So let's get started by talking about our reciprocal function, okay? So we're going to go ahead and start with a given function. And in this case, our f of x is 6 over x, okay? Now I picked 6 over x and not 1 over x just because this gave me more nice numbers to plot, okay? And so we have a table of x values here, and all we're going to do is plug those numbers in to find the f of x value or the y value that goes with it, okay? So if we plug in -12, we get 6 over -12, which reduces to -1/2. If we plug in -6, we'll get -1. If we plug in -3, we'll get -2. If we plug in -2, we'll get -3. If we plug in -3 or -1, we'll get -6. Now, if we plug in -1/2, 6 divided by -1/2 is -12. Okay. Now, if we kind of keep going with all these other values, we're going to get the same values we got the first time, except They're going to be positive because our input values are positive. So 6 divided by 1/2 is 1. Then we have 6 and 3 and 2 and 1 and 1/2. Okay. So let's go ahead and plot these points here on our grid. Let me zoom in a little bit so we can see the table as well as the graph. Okay. So I'm going to plot these points at -12. I've got -1/2. At -6, I've got -1, -3, -2, -2, -3, -1, -6, -1/2, -12. Now I'm going to plot the other points. So at x equals 1/2, I have a y value of 12, 1, 6, 2, 3, 3, 2, 6, 1, 12, 1/2. All right, so we've plotted all our points here, and you might notice that there's one point that we usually try plugging into our function that we didn't actually plug in. And that would be what goes right in between -1 and 1. Okay, so normally we try and plug in 0. So let's see what happens if we plug in 0. We get 6/0. Now I'll give you a moment to plug that into your calculator, see what you get, but you should get an error. Okay. And that's important because when we have a number divided by 0, so we have a number on the top like 6 and we divide it by 0, the calculator is going to tell us error, but what it looks like on a graph is actually a vertical asymptote. Okay, that's where the vertical asymptotes come from. When we have a number divided by 0 on the graph, that looks like a vertical asymptote. So I'm going to go ahead and draw in my vertical asymptote. Let's use orange. Okay, I've got a vertical asymptote right at x equals 0. Right? And so if I were to write an equation for that, I would have that my vertical asymptote is x equals 0. Okay. Now let's connect the dots that we have. So I've got this part right here. That's one branch. Okay, we call it a branch. And then on the other side, we have another branch. Okay. And so what's special about this 6/x function, or the reciprocal function, is that it has a vertical asymptote and it has 2 branches. Okay, so let me write that in. We have 2 branches. So we don't connect the left branch to the right branch. We have a vertical asymptote at x equals 0, and that again is our orange. Okay. But there's actually one more feature about this graph that is important. And what that feature is let's look at the end behavior here. Okay. So I notice at this end that the curve starts to flatten out. And I might even say that it starts to flatten out to a y value of 0. Meaning as I extend this curve all the way out, that number, the y value of those points are going to get closer and closer to 0. Well, let's check and see if that happens on the other end. Does that left end flatten out to a y value of 0? And I think we would agree it gets pretty close to 0, but it's just going to be a little bit less than 0. Okay? But the more important part here is they are flattening out. And so when a function flattens out at the ends, that's actually how we know that we have a horizontal asymptote. And we have the horizontal asymptote at the y value that the curve flattens out to. So if we were to draw in our horizontal asymptote here, let's do yellow, that's going to be right here. And let's label this as the horizontal asymptote at y equals 0. Okay. So when we sketch these graphs, here are a few important things. I want us to know the location of the branches. Okay, so we're going to go for the location of the branches. I want you to draw in your vertical asymptote and horizontal asymptote. Okay, so make sure you draw in those asymptotes. Now, the center point that we're going to use to kind of help us with the graph transformations is going to actually be this point right here, okay? The intersection of the horizontal and vertical asymptote. So let's write that out. Our center point is at the intersection of the horizontal asymptote and the vertical asymptote. That's going to be our nice point that we kind of move around the graph when we need to do graph transformation. Okay. All right, so let me just zoom back out for a moment. On one screen, you have the reciprocal function, you have a table full of numbers and a picture of the graph, as well as some of those important characteristics of that graph. Okay. All right, so let's get to our parent function organizer. So when we see the reciprocal function, the equation that we want to use in general is going to be f of x equals 1 over x, okay? 1 over x. Now what we're going to find is that every reciprocal function will have a horizontal asymptote as well as a vertical asymptote. And so we want to make sure those are there. But then we're going to go ahead and sketch our branches. So we know we have one branch over here. And we actually have another branch over here. Okay. Now I think when we look at this, we can tell that it's not an even function because this branch doesn't flip to an identical branch on the other side. Okay, so this is not even. But if we think about what it means to be odd, okay, it means that we're going to go ahead and reflect over the x and over the y. And so if I reflected one branch over the y-axis, I would get one kind of like this. Okay, so this is over the y-axis. And then if I reflect it one more time across the x-axis, it actually matches with the original function that I had there. So that second one is over the x-axis and the y-axis. And so since the branches match up, we have a function that is odd because it is symmetric. Well, that's not how you spell that. It is symmetric about the x and y. Okay. All right. Now, we can actually go ahead and fill in our horizontal and vertical asymptote equation. So let's go ahead and do that before we talk about domain and range. So my horizontal asymptote is going to be at y equals 0. And my vertical asymptote is at x equals 0. Okay? Now, if I think about the domain, we want to think about what numbers can you plug in for x. And if you have a vertical asymptote, that's going to be the place where there is no input value. okay? So for our domain, we can say that it's everything from negative infinity to 0, but we don't include 0, so we put a parentheses. And from 0 to infinity, okay? And we get that 0 from this 0, okay? The vertical asymptote tells us about restrictions on our domain. Well, what about the range? It turns out that the horizontal asymptote tells us about restrictions on the range. We can go from negative infinity all the way to 0, but we don't want to include it, so parentheses, and from 0 to infinity. Okay. All right. It seems like my video has stopped sharing, so I'm going to pause this for one moment. All right. Sorry about those technical difficulties. But what you didn't see when I was writing before is I was saying that when y equals 0, that's going to tell us where the range is going to have restriction. Okay. So the vertical asymptote impacts the domain, whereas the horizontal asymptote impacts the range. Now let's talk about our left and right end behaviors. So when my curve goes all the way to the left, okay, so like this part right here, the y value it's getting close to is 0. Now when I look at the right end, what is that y value getting close to? Well, that's also getting close to 0. And that's actually one of the indicators that we have a horizontal asymptote. If the left end behavior and the right end behavior are equal, so if these are equal, then guess what you have? You have a horizontal asymptote. Okay, so horizontal asymptote means that the curve flattens out and that the end behavior should be the same as your horizontal asymptote. Okay, so let me zoom in for a moment so you can get the whole reciprocal function on one page. Feel free to pause here if you need to copy that down. But what we're going to do next is we're going to apply this parent function to graph transformation. Okay, so we're going to go back to our CBAD, our horizontal shift, horizontal stretch or shrink, a vertical stretch or shrink, and a vertical shift. All right, so let's jump right in. Okay, so if we take a look at example 1, we can see that we don't have a C value, we don't have a B value, but we have an A that is negative. Okay, so this negative sign, what does that tell us? Well, it tells us a reflection over the x-axis. Okay. And what about that -4? Well, that -4 tells us that we shift down 4 units. Okay. So here's what we're going to do. If we don't move side to side, then our vertical asymptote stays the same. But if we move our function down 4 units, our horizontal asymptote is actually now lower. Okay, let's write those equations in before we get too carried away. We've got x equals 0 and y equals -4. Okay. Now remember what we said about our center point. Our center point is actually the intersection of our horizontal and vertical asymptotes. Now let's think about our reflection. So the reflection means that instead of a branch being up here, it's going to flip over that yellow line and be down here. And instead of the second branch being down here, it's actually going to be above the yellow line. Okay. And so this, without the question marks, let's get rid of the question marks, that is a graph sketch of your f of x equals negative 1 over x minus 4. Okay. Now, if you're thinking about the order of graph transformations, then what we need to make sure we do is that we actually reflect it before we move our function down, okay? All right, let's take a look at example 2. Example 2 says f of x equals x plus 6. So the only thing that's happening here is we have this plus 6, which means we shift 6 to the left, okay? Now that is going to change my vertical asymptote. And this vertical asymptote is now going to be at x equals negative 6. Now, we didn't move it up or down any, so does our horizontal asymptote move anywhere? Well, no. The only thing we did was move things to the side, 6 units. So our horizontal asymptote can be the same as the parent function, and its equation is still y equals 0. Now there's no reflection like example 1, so we just sketch in our branches, 1 here and 1 here. And if you want to, you can remind yourself that the center point is at the intersection of your horizontal and vertical asymptotes. All right, let's move on to examples 3 and 4. So what's happening here? Well, it looks like we've got a shift sideways at -2, and it looks like we've got a shift up of 3. So this -2, which comes first, means to the right 2, and this +3 means up 3. No reflections, but our asymptotes are going to change. So let's do the one to the right first. If we're moving to the right 2, then my asymptote moves to the right 2, and it becomes x equals 2. If we move the graph up 3, guess where our horizontal asymptote is? At at y equals 3. And then all we need to do, we could put in our center point at that intersection. And then we're sketching a curve in the top right part of the asymptotes and an intersection or another branch in the bottom left. Okay. All right. Well, it looks like example 4 is pretty similar, but we're moving things in some different directions. So x plus 2, well, we know that means we go to the left 2. And this -5, well, if +3 means up 3, then I think we know this -5 means down 5. Okay? So let's sketch in our vertical asymptote first, and this time I'm going to draw it to the left. And let's sketch in our horizontal asymptote, and that's going to be down 5 units. I know this is my center point where they intersect, and I'm going to write out the equations for the asymptotes before I forget. Y equals -5 and x equals -2. And then, since there's no reflections, we sketch one branch in the top right of the asymptote crossing and another branch in the bottom left. And that's it. Okay? All right, let's take a look at these last two examples here. This is probably a good time to maybe pause the video, try these on your own, and then come back and check the answer, okay? All right, so hopefully you've had a chance to look over example 5 and 6 now. Let's identify what's happening here. Well, we have an x plus 3. So we know that moves to the left 3. And what color did I use above? Pink. Okay. Well, there's a minus sign in front again, this pink one, and that is going to say the same thing, which is reflect over the x. Okay. So let's sketch in our vertical asymptote first, because that's what moves when we shift it to the left 3. So our vertical asymptote is going to be somewhere around here, and we'll label this as x equals negative 3. Now we're not moving up or down any, so our horizontal asymptote stays exactly where it is, and we can label this y equals 0. Now, because of the reflection, the branch that was in the top right, like up here where the question mark is, that one gets reflected. So now it's in the bottom right, okay? And the branch that was in the bottom left, well, that one gets reflected to be in the top left now, okay? So let's get rid of those question marks so we know they're not part of our graph, but the reflection is what causes the branches to be in different parts of the sort of quadrants, if you want to call them. Now we can still draw in that intersection point so we know where our center point is, okay? All right, we got one last example. We've got f of x equals 1 over x plus 7. So only one thing is happening here. We are moving up 7 units. Well, if we're moving up, that means that my vertical asymptote is going to stay where it is, and we can label this as x equals 0. However, our horizontal asymptote is going to move up to y equals 7. And we can draw our center point in. And because there's no reflection, we've got one branch in the top right and a second branch in the bottom left, okay? So let me zoom back out so you can see all of these practice problems on graph transformations on one page, all right? But that's gonna wrap up our video here for 3.7 part 1. So when you come to class, make sure you bring some specific questions. We're gonna work on a few graph transformations together just to make sure we've got the hang of it. And then we're gonna move right on to 3.7 part 2, okay? All right, thanks so much, folks. Have a good day.